This video will show the reaction between potassium chlorate and a gummy bear, or more specifically, sucrose. The first step is to weigh out about 5 grams of solid potassium chlorate. There we go, we have 4.9 grams. That looks good. So now we're going to put all the potassium chlorate into a test tube. In this case, we have a broken test tube because this experiment can get a little explosive and we don't want to damage perfectly good glassware. And then we're going to set up the test tube in a ring stand and turn on the Bunsen burner, and we're going to heat the potassium chlorate until it is all melted. And this part should take about 5 minutes, but we're not going to watch 5 minutes of potassium chlorate melting because that would be very boring for everyone involved. So let's get to some stuff exploding, shall we? This is very stressful. I got this, Marlena. Oh my god! So as you can see, lots of purple flame, lots of noise, lots of steam. What's causing all this? Originally in the test tube we have potassium chlorate, which looks like this. And then when we heat it, it decomposes into potassium chloride and oxygen, or O2, according to this reaction. Gummy bears are mostly made of sucrose, which reacts with oxygen according to this equation. So when we added it to the test tube, the excess oxygen formed from the thermal decomposition of potassium chlorate will oxidize the gummy bear, and the oxidation of sucrose is an extremely exothermic reaction, which means that lots of energy is released and the enthalpy of reaction is negative. This means that weaker bonds are broken than are formed, because forming bonds releases energy. In this case, the enthalpy of reaction is about negative 5,000 kilojoules per mole reaction. The energy released in an exothermic reaction can take a number of forms. In this case, it was released in the form of heat and light. But that doesn't answer the question, why was the flame purple? The purple flame is due to the presence of the potassium cation. Now, when metals of ions are heated, the electrons move to a higher, less stable state, and when they return to their ground state, the excess energy that was built up is released in the form of light of a certain wavelength, which is characteristic of that element. In potassium's case, it's purple. One last thing.
I did not expect the noise!
Wow.
Whoa, okay, that's flames. That's going off.
Turn off the Bunsen burner before you add the gummy bear, or else flames will happen. Yep, we lit that on fire. That was not supposed to happen.